lagging tardy, late. You know, there are sanctions for those things. And that's the reason from the beginning I had explained to you all that you have to you ensure that your presence on a Google platform and you treat that the same way like you're in a physical classroom. So like I said, you know who you are. There are some of you that I would have contact or tell you over class like this, but I will no longer do that. So when you see any effects on your grade, then there will be nothing that will be up for discussion. I just want you to understand that there will be nothing, especially you know that you have been absent for a couple period of time, and then there is no type of contact that you have made with me to see the reason why that is so. So, like I said, you do your thing, and at the end of the day, I do my thing, and that's it. Okay, let me call the attendance. Franceli Aguilar.
Here, sir.
Okay, I'm back on screen. I noticed that I had lost contact. So the network was giving problem here. So I'll be calling the attendance. Franceli,
Here, sir.
Herman, Aldana,
Here though.
Ashby, Awe, Ashby. Okay, Ashby is that here. Karen Barrera,
Here,
Karen
sir.
Damaris Blades,
Present.
Rachel Blanco,
Present.
hmm, um, Shanice Blanco, Shanice. Okay, not here. Liane Cal,
Present.
Linnell Cal,
Present.
okay, Ashby is already in. Let me put her. Kaylee Kamal. Kaylee Kamal. Kaylee Kamal. Brittany Kamal.
Present.
Shanti Kano.
Morning, sir. Present.
Naveen Kavio. Naveen Kavio. Kiara Castellanos.
Present.
Emily Chan.
Present.
Alanis Colendres.
Present.
Cherie Edwards.
Present, sir. Good morning.
Good morning, Cherie. Jency Enamorado. Jency. Joanna Garcia. Joanna Garcia. Kiana Quillen. Kiana Quillen. Owen Martinez.
Here, sir.
Oziel Mendez.
Present, sir.
Vire Navello. Vire, you are one of them. You have to really watch out. You have been absent for a lot of sessions. Aisha Novello.
Present, sir.
Jonathan Pook.
Present, sir. Good morning, sir.
Okay, good morning. Azali Ramirez.
Present.
And Elvis Solis.
Present, sir.
Okay. Jamile Tayub. Jamile Tayub. Okay. Once again, there are several people I will go because when I close, Shanice Blanco. Kiele Kamal. Naveen Kavio. Jency Enamorado. Joanna Garcia. Kiana Quillen. And Jamile Tayub. Jamile Tayub. Wow. Okay, Kelly just came in. Kelly?
Morning, sir.
Okay, let me close my attendance now. See. Give me 1 second here. Last time we were looking at the discrete random variable, whereby the summation of all x, the summation of all x for the probability discrete function big X equal small x is equals to 1. And we tend to use that concept to have solved or to work out different problems. So the one in red, this was what we were using. And these were some examples that were given to you, whereby the summation of all x, the probability of the discrete random variable big X equals small x is equals to 1. So also I emphasize that the it should never be less than 1 or go beyond 1. From the moment you add the probability of a probability density function, then it has to add up to 1 at the end of the day. So we did this example to have showed you that, and we have done several other examples pertaining to. So this is the one that we were looking at, P10. So we did these one as well. These were the examples that were given to you. And this was the last question that we touched that day, whereby no, that wasn't the last one, but we look at that. And then there was a word problem that we basically look at as well. Let me see if this is this one here. Yep. So this was the one that again consists of throwing tennis ball into a bucket. I have went through this one with you. This was the last one that we look at. And they mentioned to construct the probability distribution for X, the number of tennis balls that land in the bucket in a turn. William wins a prize if William wins a prize if at the end of his turn there are 2 or more tennis balls in the bucket. What is the probability that William does not win a prize? Okay, that's look better. So we went through that. Remember it said William win a prize if at the end of his turn there are 2 or more tennis balls in the bucket. What is the probability that William does not win a prize if there are 2 or more? So is this problem finished? Is this problem finished? Hello? Are you with me?
Yes, sir.
Remember, William will win if his 3 attempts is if he got that X is equal, greater than or equals to 2. But they want to find out here, what is the probability that William does not win a prize? The probability that William win a prize if there are 2 or more tennis balls. That's what we found here. So the probability that he does not win the prize will be what? There are 2 ways that you could have done this if you get less than 2 tennis balls, which was adding these 2. Or we have found this already, so we subtract it from 1. So if we say let's the probability that, let's call that A. A that he does not win. So that would be A, complement A, okay, that he wins, provided, so this would have been the probability of A, which would have been 0.3. So let me just put that in here, just to make a, like that. So the probability of A complement will be equals to 1 minus the probability of A. So the probability of that, let me just copy and paste. So what value will go here? 0. If I'm not getting
352, sir.
Okay, 352. So which means then that the probability that William does not win a prize will be what? When we take the difference. When we subtract 0.352 from 1, what do we get? People, I told you should have a calculator. Hello, what would we get? Hello, are
Sir,
you still
0.648, sir.
0.48?
648. Yep.
Okay, so that's the answer, that William does not win a prize. Because in order for William to have won a particular prize, then he should have achieved 2 or more attempts. So he should have been successful in 2 or more attempts. So in order for him to be successful, the probability was 0.352. So for William not to be successful, then we do the negation of that, whereby we subtract the successful outcome from 1, which will give you the unsuccessful outcomes. Remember, I told you that adding the successful outcome with its complement, you should always get 1. So if we add the successful outcome, which was 0.352, with its complement, then we should get 1. So that's just basic rule of thumb. Now let's look at this one here. Yes, this is the one that we did last time. Emma plays a game in which she chose 2. Then write out the probability distribution of X the among Emma gains in 1 turn. So we have looked at this as well using the factorial. So we mentioned then that if she pays 5 pence per entering the game, so which means then that if she didn't get any 6s, then she have lost -5. If she obtained 1 6, then she wins 10 pence, but her gain will be 5 cents or 5 pence. So we have looked at that. Now our next topic will be finding the expectation or the mean. Expectation or the mean. So when we are asking about finding the mean of a discrete random variable from a probability discrete distribution, then we are actually finding the mean mu. Remember, there's another symbol for mean which we used was mu. So we could say that will be expectation, which is the mean. And this is the formula for expectation. And also what I want you to know, that expectation is also referred to as mu, this symbol. So this is the mean, or EX is equals to mu. Okay, so you cannot be seeing this symbol sometimes, meaning mu, that's the mean, and it is pronounced as nu. Okay? Now let's look at this example. Number one, the probability distribution for the random variable x is shown in the table. They want us to find EX, which is the expectation there. Now remember, the formula used here will be the expectation. EX represents expectation. EX is the expectation. And it is equal to the summation of all x, where small x is being multiplied to the probability distribution of big X equals small x. So what is the difference between the expectation formula and the one that we previously had? It was yeah. So what is the difference between this formula, the summation of all x, the probability of the discrete random variable x equals small x equals 1? Now this one is saying that the expectation is equal to the summation of all x per small x multiplied to the probability of the discrete random variable x equals small x. So what differentiates this formula from the previous one? Students, are you still on?
Yes, sir.
Students? Yes, but I'm not getting any response. Maybe I have to give a quiz. Let me see what time. Yeah, I have enough time. I will upload one, and then I will see whether you know or not, because I'm not, only one person is actually participating. So maybe I have to do that after I complete this question and give you one, and that will combine everything, and for you to upload at the end. So what differentiates this formula from the previous one? Some people are still not participating. Again, what differentiates this formula from the previous one?
Sir, isn't it has to do with like the x in the first formula and the x in the other formula, sir? Meaning like this bigger x and that will equal the smaller x, sir? Isn't it the way it is structured, like for us to find the values?
Yes, the other one, if you notice, the x is not in front. And we said that the summation of all x without this small x in the front, that is equals to 1. But in the expectation, we have the all x is still the summation, but then in this case, we're gonna be multiplying the small x to the discrete random variable big X with the probability that it takes. So we're gonna be looking now at an example here. It said the probability distribution for the random variable big X is shown in the table. So we have the values of small x. These values of small x is the x that you're seeing here in the formula. So this here small x here, let me put it in red, is these values x that are up here. And then the probability of big X equals small x are the ones that are below. Now, So what we do here to find the expectation, we just state the formula like this one, and then we set EX is equal to the summation. So it's the value small x times the individual probability. So that will be 0 times 1 over 6. And that will then be 1 times 112, 2 times 1/4, 3 times 1/3, and 4 times 1/6. So when we continue solving that, so this is at the, okay, we get 112, because 0 times 1/6 is 0. This is 112. This will be a half, because 2 times 1/4 to cancel. This will be 1, and this will be 2/3. And then when we put that in our calculation, EX is equal to 9 over 4, which the expectation is 2 1/4 or 2.25. Now, remember, this is expectation. This is not probability, because then some people might be saying, but sir, how that value is greater than 1? We are finding the mean. This is expectation. We are not finding probability. So you will notice that finding expectation, that you will be finding values that are large. And you will notice that sometimes your expectation would be negative too. In some cases, it might be asking you if there was a gain or if there is a loss. Find a gain or find a loss. So wherever you obtain, if you obtain a negative value, meaning then that you have a loss. And if you obtain a positive value, meaning then that you have gain. Is that clear to everyone?
Yes, sir.
Okay, these are expectations. Let us look at a question. Okay, this was the first one that we did. I like this one. This was the one that I want to give you right now to see how well you can do. Because already you should be able to deal with this type of problem. This one is to find mu. This one is asking you to find y and the expectation. This one is only asking you to find the expectation. So to find the expectation here, we have done this one. In order for us to find the expectation here, then we're gonna do the same process. We state the formula, then 5 times this probability, plus 6 times this probability, plus 7 times this probability, plus 8 times this probability, plus 9, and then whatever we obtain, we add them up. And then that will give us mu. So mu, remember I told you mu is also mean EX, which is the expectation. Everybody got that?
Yes, sir.
Yes, sir.
Okay. Let's look at, it said find the expected numbers of heads when 2 fair coins are tossed. Let's look at this basic one first. Basic mathematics. So we are looking here. In fact, let me I will continue right here. Okay, what's the first thing that we need to do here?
Do our table, sir?
Okay, we need to do our table. Okay, let's do that then. Now, what values small x can take?
One and two,
Remember
sir?
when we were looking, there are two heads that are being thrown, right? Two, it said find the expected number of heads when two fair coins are tossed. Remember this here, let me go back. I think we have a problem similar that we did in the other one, or the same one upstairs here. With the coins. Now this is the ball. Then I had another one that I gave you with the coin. Well, anyhow, I gave you that already. I won't be wasting time with that. I have it said here that we have two coins and the expected number of heads. So the number of heads will be the discrete random variable x. So what is the possibility or the probability of getting heads when we are throwing like two fair coins?
Two, sir?
Yes, it said here, two fair coins are tossed. I remember when we were looking at probability of a coin, it's for each side is a half. Because a coin only has two faces, but they're throwing two coins, and each coin is independent. Remember, we look at this? So I could get 0 heads. Yes, I could get 0 heads by getting 2 tails. I can get 1 and 2. Isn't that so?
Yes, sir.
Yes, sir.
Yes, sir.
We have done these already. So the probability of us getting 0 so we need to get 2 tails, a tail and a tail. And the probability of getting 2 tails, that will simply be so this will be a half on the first coin, and it cannot happen, and then a half on the second coin. That this can only happen in one way. And this will give us 1/4.
1/4.
So what will be the first one here?
Sir, wouldn't it be a tail and a head, sir?
Yes, that could be. I remember it's two different coins, or I remember you need to get one tail, right? So it could be a tail and a head. And I will put that as 2 factorials. Because remember, it's two objects where two, right? Two objects here. I can have a tail and a head, and let me just list it. Or just two here, 2 factorial. Because it's two different objects, 2 factorial. Because we have two objects in line and there's nothing alike. And remember, you could have obtained a head first on one of the coin and a tail on the, let's say I have a silver coin and a gold coin. But both of them have head and tail. So you could have obtained a tail on the silver and a head on the gold. Or you could have obtained a gold, a head from the gold and then a tail from the silver. Isn't that so?
Yes, sir.
Okay. So which means all I need to put here 2 factorial is 2. So in other rounds, this will be a half, right? Everybody agrees? Because that would have been 2 times 1/4.
Yes,
4
sir.
times 2, so that would be a half. So I can put this here, copy, and I can paste that here. Okay. These things are basic, you know. Just need to understand the principle behind it. So what will come next then? What will come next?
The 2, sir?
Okay, the 2. And how can we get 2 heads?
Wouldn't it be 1 time, sir?
Yes, only one way, head and a head. So we're gonna move this 2. And then this will be 1,
1/4.
1/4. And if you were to add these up together, what do you get? You have to get 1. Check this out. What will you get? Come 1/4 and 1/4 is a half, and a half and a half will give us 1.
1,
right?
sir.
Yeah. Now they want us to find the expected number. So that's the expectation. So let me just copy this. And retrieve this to expedite the process. So this is what they're asking now, the expectation. So that will be 0 times 1/4. That will be 1 times a half. And 2 times 1/4. The 1/4 is there already. So E of x will be equals to, this will give us 0. You don't need to put in the 0, but that will give us a half. And then this other one will give us a what? Plus
a half as well.
a half as well. So in this case, the expectation is
1, sir.
1. So EX okay, EX is equals to 1. Okay. Any questions?
Sir, do we have to show like all the steps for the expectations, or can we just plug in
Yes.
all the values in the calculator?
No, you could plug this in, and then you need to show this step. And then from there you could evaluate. Because sometimes, like this one that I showed you, if you notice, you have to show me this step and this step. And then from here, you could go straight to the answer. I don't need no other simplification.
Okay, sir.
Okay. Now, let's look at the second one. Start off with some basic ones, like I said. Then from there, I'm gonna hit the bomb. These are so basic. I don't like this. Yeah, it didn't show everything. No. Okay. So this will be edit, copy. It said here a bag contains 5 black counters and 6 red counters. 2 counters are drawn one at a time and not replaced. Let X be the number of red counters drawn. Okay, the number of red counters drawn. Let me get rid of this. It's this one. Okay. So the first thing what we need to do, so okay, it said 2 counters are drawn one at a time and not replaced. Let X be the number of red counters drawn. So So we have two types of counters. We have black and we have red. So let's state our events here so we can say that we have B to represent the black counters. Okay, and we could use R to equals the red counters. So NS for now, but we know it's without, so NS is equals to 5, and so we have, I should have gone and put before I put NS. Yeah. NS, I will put the NS one time. So what will be NS? What will be the sample space?
Isn't it 11, sir?
Okay, it is 11. Okay, and they mentioned that, let me put it here, that the number of black is equals to 5, and the number of red is equals to
6, sir.
6. Okay. Okay, let me do it the proper way. So, what values the red can take? Remember, the discrete random variable x is the number of red counters drawn, and they mentioned that 2 counters are drawn one at a time and not replaced. So what would be the values that it can take for the red counters? How many counters are being drawn?
6, sir.
Read the problem here. It's how many counters?
2, sir.
2.
2, sir.
One at a time and not replaced. So, and they mentioned that the random variable x is the red counters. So what we need to do here is as follows. We could get 0 red. Why? By drawing 2 what? 2 black. We can draw 1 red out of the 2 by getting a black and a red, and the other one a red or a black. Everybody agrees?
Yes, sir.
Yes.
And then we can get 2. 2 red by drawing a red and a red. And there is no other than that. Now let me just go and to expedite this process. Yes, let me copy this here. And let's see. Let's see. Copy. Right now it's says not responding. Are you still hearing me?
Yes,
Yes,
sir.
sir.
Okay, let me
Yes,
see what. Okay, I don't know why this is not said not responding. Okay, let me go back and deal with it. Go back here and then go back. And that. Word not responding. Okay, we wait until it responds. I already think I know why that is so. If I close this, I hope I don't lose this here. I think it can recover. Like, just give me a break here. Put it right here. I just need to give it a little while here. Right now. Where could I have these? Usually, this would have had this document here. This would have this there, this there, this there, this there. Everybody still with me? Hello?
Yes, sir. We're here.
Hello?
yes, sir.
Okay. I think this was the one. It seems like you have lost some problems. Yeah, and the time is up already. I have to go back and see where to recover that. Because I don't see what happened to those two. Or it is this. Let me see. Yeah, this was this one. Yeah, these ones are okay. Okay, we're gonna leave it like that. And till when we meet tomorrow, I have to recover those ones that are there. Okay. So have a nice day. Have a nice day.
Thank you, sir. Bye. Same to you.
Okay, bye. Okay, Shanti.